In this video, we're going to look at rotations. When a shape is rotated, it stays the same shape and size. Its position and orientation are changed. A rotation requires three things: a centre of rotation, an amount of rotation, so an angle, so 90 degrees or 180, and a direction of rotation, either clockwise or anti-clockwise. To rotate a shape, what you should do in an exam or anything like that is to ask for tracing paper. It makes it so much easier to do so. And what you would do is you'd mark the centre of rotation, put the tracing paper over both shape and the centre of rotation, trace the shape line and line it onto the paper, put your pencil point on the centre of rotation and turn the paper through the appropriate angle and draw the transformed shape in its new position. For the purpose of this video, I'll talk through a different method rather than just the trace and turn method. So rotate shape A about the origin, so that's about 0, 0. And that's 90 degrees clockwise. So we're going to be going in a clockwise direction. So what we do is, in this alternative method, is to think about L shapes. So to get from the origin to the first point on A, we go across 3, right 3, and up 2. And that shape rotated 90 degrees clockwise is going to be an L shape, down 3 and right 2. So if we trace that shape from the origin and go down 3 and right 2, we get the image point to be at the point 2 minus 3. Next we have to get from the origin to the furthermost point. So we go right 6 and up 2. So if we draw an L shape for that, we go right 6 and up 2. And the rotated shape from there is going to be down 6 and right 2. And if we go down 6 and right 2 from the origin, we'll get to the point 2 minus 6. And then the last point, to get from the origin to the top point, we'll go right 3 and up 6. So if we consider that L shape, and then rotate that about the point, we'll go down 3 and right 6. And that'll get us to the point 6 minus 3. So if we join those points up, we get this shape, and I'm going to call that A dash. Then we need to go for the next one, which is 180 degrees about the origin. And we'll see that there isn't a direction this time, and that's because it doesn't matter if you go clockwise or anti-clockwise. We're going to use the same method, which is these L shapes. So from the origin to the first point, that was right 3 and up 2. And if we rotate that 180 degrees, we'll go left 3 and down 2. And if we do that from the origin, left 3 and down 2 gets us to the point minus 3 minus 2. Then for the furthermost point, it's from the origin, we go right 6 and up 2. So right 6 and up 2. And that reflected is going to be left 6 and down 2. So left 6 and down 2 gives us a point of minus 6 minus 2. And then the last point, from the origin we go right 3 and up 6. And that rotated 180 degrees would be left 3 and down 6. And if we do that from the origin, we get to the point minus 3 minus 6. And joining those up, we get this triangle, and we're going to call it A double dash. Example 30, rotate shape D. Part A, 90 degrees anti-clockwise about the point 2 minus 1. So 2 minus 1 is here. And if we think about our L shapes, to get from our point to the bottom of the triangle, we go left 3 and up 2. And a 90-degree anti-clockwise direction is this way. So from this point, we'll be rotating it anti-clockwise, and it'll be down 3 and left 2. So down 3 and left 2 from our centre point is the point 0, 4. To get from our centre to the next point, we go left 4 and up 6. And if we rotate that in an anti-clockwise direction, we'll go down 4 and left 6. And from our centre, if we go down 4 and left 6, we get to the point -4, -5. And then the last point, to get from our centre to our top point, we go left 1 and up 7. And that rotated in an anti-clockwise direction will go down 1 and left 7. So down 1 and left 7 from our centre will take us to the point -5, -2. And joining those points up, and I'm going to call this D1. What transformation then would return the image to its original? Well, that's just going to be the reverse process. So what we'd have is a 90 degrees clockwise about the point 2, -1. Or, of course, it could be a 270 degrees anti-clockwise rotation there. Part B then, what we're going to do is rotate it about the point 0, 4. So 0, 4 is here. And we're going to rotate D about it. So what we're going to do is measure each point. So to get from here to the top, we'll go right 1 and up 1. Up 2, sorry. 1 and 2. And we will rotate that 270 degrees clockwise, which is actually 90 degrees clockwise. That's going to be an easier way to do that. And clockwise is in this direction. So if we rotate 1, 2, we'll go down 1 and right 2. So down 1 and right 2 from our centre will get us to the point 2, 3. So that's our first vertex. To get to the next one, we'll go left 2 and up 1. Left 2 and up 1. And that rotated in a clockwise direction will go up 2 and right 1. So we'll go up 2 and right 1. And then we're here. And then the last point is the bottom one, which we'll do as down 3 and left 1. Down 3 and left 1. And that rotates to left 3 and up 1. So we'll go left 3 and up 1, and that'll take us to the point -3, 5. And joining those up, and I'm going to call this one D2. Now, to describe a rotation fully, what we need to do is give the name of the transformation, so in this case would be rotation, the amount of rotation, so that's really the angle that we're thinking about, the direction of the rotation, so that's clockwise or anti-clockwise, and then the centre of rotation. So for instance, we could have an example of 90 degrees rotation, clockwise about the point 47. Again, we wouldn't really need the rotation direction if we had an angle of 180 degrees. The way we can find the centre of rotation can be done with trial and error with tracing paper. So you pick a point, you trace the shape, and then you try and move it and get it back to the object. Or you can do a method with perpendicular bisectors. So the method of perpendicular bisectors can be done properly using constructions or done roughly to give us an idea of where the centre might be, and this can help us with our trial and improvement method. A perpendicular bisector is something that cuts something in half at right angles. So if we have our 2 points, what we could do is join them up with a line, and then the perpendicular bisector will split that at 90 degrees in half. So it would look something like that. And if we were to do that for each corresponding point, then all the perpendicular bisectors would go through the 1 point, which would be the centre of rotation. So example 31, mark the centre of rotation by using the method of perpendicular bisectors. So the first thing we do is we join the points A and A dash, and we draw the perpendicular bisector of those. So there's A and A dash, and the perpendicular bisector of A and A dash are all the points along this. Then we join the points B and B dash, and if we draw the perpendicular bisector through there, and we get this line here, that's right angles to the line joining B and B dash, and it's in the middle of it. And then if we join our point C and C dash, and we join the perpendicular bisector through it, so the line that cuts the line in half and is perpendicular to it, we get this line. So what we have is that the lines all go through this 1 point, which is our centre of rotation. Example 32, describe fully the transformation which maps P onto Q. So we've traced out P, and what I want to do is rotate it and see what sort of an angle is going to take me onto Q and what direction it will also be. So I'm rotating my shape in a clockwise direction, and I've passed through 180 degrees, and we'll stop here at 270 degrees. So what we can see is that we've got a rotation, which is the first thing we need to see. It is 270 degrees clockwise, or that would be 90 degrees anti-clockwise. And then what we need to do is find the point. And what we do is we join our corresponding points and find the perpendicular bisector. So when we join the two corner points, the blue line is the line connecting those, and the red is the perpendicular bisector. I've joined the bottom points and marked on the midpoint of the line, so now I need to draw the perpendicular bisector. And what we can see is that both these points pass through the one common point, which is the origin, so then the rotation is about the origin, so 0, 0. Example 33, how do we get from Q onto P? Well, first thing we can see is that it's rotation. It's a rotation of 90 degrees anti-clockwise. And we can tell that because the base length of Q, so this length, to get it so that the corner is on the bottom left, it's been rotated in this direction. So the top of the point is going around, and we're only going through 90 degrees to get there. So what we need to do is find the centre, and the centre is going to be somewhere in around here. So we'll do the bisector method to find that. So joining corresponding points, and then finding their bisectors. So I'm just going to join 2 points, and I've marked in the midpoint, so now the bisectors. So we can see that the two lines, the two bisectors, go through the point 0, 1. So we've got a rotation 90 degrees anti-clockwise, and that's about the point 0 minus 1. And obviously in an exam you would write anti-clockwise for this, or clockwise if it was appropriate. And of course we could say that this would be 270 degrees clockwise, so it would be appropriate.